All right, good morning, everybody, and welcome to the Potter webinar on our Addressable series panel software. I'm James Brennan. I'm going to be the webinar presenter today. I've been working for Potter for about 3 years. And previous to my career with Potter, I spent almost 20 years in integration, doing everything from being a technician to project management, etc. So, with no further ado, let's go ahead and jump into our software. This is the Potter Fire Panel Programmer software. And the first thing that I would like to do is we're going to do a little tour through the software so I can show you where some of the key things are that we need in the software. Up top here, we have the Windows ribbon. And from right to left, first thing we have here is Help. And when we select About, that shows us the version of software that we are currently running. In this case, 12.1.2.0, which is the most up-to-date production version of software that we have. Below that, we have Show EULA. That's the end user license agreement. That's just the legalese. Finally, below that, we have Check for Updates. I will say in version 10 and greater of the Potter Fire Panel Programmer software, there is an auto updater that's baked into the software. So if you have internet access and there's a new version of the software, you open the software, a little pop-up will show that there's a new version available. It'll even give you some Cliff Notes versions as to what's in that new software package. Most of the time, it has new product support. It is also worth pointing out that more often than not, if there's a new version of software that's been released, there is more than likely a new version of panel firmware that has been released. And we'll talk about firmware here in a little bit, but those two generally go hand in glove. Okay, for the next one, I need to open a panel so that you guys can see. The panel that I'm going to open is really kind of irrelevant, but it's worth pointing out that the Points tab is basically just going to be data entry. That's where we're defining all of those specific points, and we'll get into more about that here in a little bit. Zones is where we're going to define those input-output correlations. The pull station makes the horn strobe go off. We're going to spend the vast majority of our time here in the Zones tab, and we have these elements here. Over here on the right-hand side are our available points. Up top is our rules window. Over here on the left is going to be our zone list. And then finally here in the center is going to be what I call the bucket. It's where we're going to drag and drop those inputs and outputs to make those things activate. Now, we can take these individual windows, and if you got a little push pin here, we have the ability to undock them and move them around. Now, I've got multiple monitors here on my computer, so when I program, I like to move my points over to another screen. But we also have the ability to run them off the screen, where obviously we're going to have a very difficult time building our zones. So if we come here to Window and click Reset Windows Layout, it's going to snap that view back to that default view. All right. Next to that, we have Options, and the first thing we have here is Preferences. Under Preferences, we have the default file folder where the software wants to save your panel configurations. I will say if we pull a configuration from a control panel and we just click Save, it is going to save that file as config_datestamp_timestamp. So you will want to change that to something job specific. I'm going to recommend using Save As. Use Save if you've already given the file a name that makes sense and is site specific to you. Below that, we have tooltips enabled. We're going to talk more about tooltips when I start doing an actual programming demonstration, but I'm going to highly recommend that you always leave tooltips enabled. There's really no reason to turn it off. When we start programming, our software has got some rules that are baked in. And if there's something that the software doesn't like, it's going to highlight that. I would refer to that highlighted portion as an audit error. And if there's an audit error and you mouse over it, it'll tell you exactly what the software does not like about the thing that we did. So again, when I get into the demonstration portion of this, you'll see what that audit error looks like. All right, next under options, we have registration. You have to register your software in order to be able to see IPA panels, to be able to see the peer-to-peer network option. The IPA series of panels is Potter's proprietary line of panels. So you have to have registered software to be able to pull a copy of a configuration from an IPA panel, to be able to write an IPA configuration from scratch, or if somebody has sent or you have a saved IPA configuration on your computer, you will need registered software in order to open that. So that software needs to see the license server. So once you register the software, that's going to be because you're a part of the license server. And the software wants to see that license server once every 30 days. So if you have internet and you open the software, it's going to query that license server and it's going to ask, is this person a valid user? And if the answer comes back yes, you'll be able to connect to IPA panels and pull their configuration, write an IPA configuration from scratch, or open a previously saved IPA configuration. If the answer comes back no, of course, you would not be able to do any of those things. Please don't think that you need to open the software once every 30 days in order to maintain this. You do not. If you open the software 6 months down the road and you're still a valid user, that answer would come back from the license server in the affirmative, and you would have the ability to do all of those things that I just mentioned. If the answer comes back no, of course, you would not. So you don't have to open it up every 30 days. But what happens if it's 6 months down the road and you don't have internet access and you open the server, and then you're locked out of all of those IPA things? You could go to options and offline code, and here you would enter an offline code. So at this point, I kind of want to explain a little bit about the license server. Potter does not maintain each company's license server. So first of all, you have to be an ESD to be in the license server. And then there are 3 levels of user within that license server. The lowest is going to be software. They have the ability to log on to pottersignal.com, and there's a dashboard and some other very useful tools that are behind that login wall. The next highest level user would be software. So that person would have the ability to log on to pottersignal.com as well as register software. The highest level user would be admin. Of course, they can log on to the website, they can register software, but then they can add and delete users within that company's specific license server. So if you get locked out of those IPA panels, get in touch with your company's administrator. They will be able to go to your user account and generate an offline code. You would type that offline code in here in options offline code, and then your software will be unlocked for those ESD functions for another 30 days. All right, under File, first thing we have is New Panel. If we are pulling a configuration from a control panel, we are not going to go to New Panel. We would just upload that configuration, and then that configuration would populate in the software automatically. New Panel is only if we're programming a panel from scratch. New network, you're only going to see this if you have registered software. That's if we're doing a peer-to-peer network. Open, close, save, and save as are pretty self-explanatory for a Windows-based software. Below that, we have password protect. I do want to talk about password protect a little bit. This is something you need to be not necessarily careful with, but you need to understand what it is, how it works, so that you can be safe. So what I'm going to say here is, if you're using any communications device, regardless of the manufacturer, I'm going to strongly suggest that you read the terms of use. A good example would be, a couple months ago, I downloaded Solitaire for my phone, And as I was installing it, the game asked me for access to my phone and my contacts. Well, it's solitaire, so of course I said, no, you don't need access to that. Anyhow, that being said, when Potter released the Intellicom Advanced Gateway, there was some notable concern about data privacy that went with that cellular communicator. So we offered the option to password protect your panel configuration file. Please understand that password will follow the configuration into the control panel. Next person comes along and tries to pull a copy of that configuration, they will have to have the password in order to open that configuration. Potter does not have a back door if you lose that password. So that's something very important to remember. We do not have the ability to backdoor a lost password that has been added to a panel configuration file. So if you're going to password protect your panels, I'm going to highly recommend that you save 2 versions of your configuration. One of them which is open and easily editable, and then the password protect version would be what would actually go in the panel. So then, worst case scenario would be if you lose that password, you have an open version of the program that you can make whatever changes you need to make. That's why you were connecting and programming that panel to begin with. Re-password protect, and you're off to the races. Okay, below that we have convert. Please understand, convert is a one-way street. So I'm going to purposely open the smallest addressable panel we have, the AFC 50. And when I go to convert, you're going to notice I've got quite a list of panels that I can convert to. So a couple of things to keep in mind here. When we convert, we have to go to a panel that has an equal or larger number of onboard circuits. So if you remember from the hardware presentation, the small format panels have 2 NACs and 2 IOs. The large panels have 6 NACs and 4 IOs. So in a minimum, we have to have the same number of onboard circuits or a greater number of onboard circuits. And then we have to have a larger SLC capacity. So I did the AFC 50, so you can see I've got quite a list there that I can convert to. If I had started with an IPA panel, so we'll do the IPA 60, and I go to convert, you're going to notice I can only convert to an IPA panel. And that is because there are functions, smoke control being the most notable, but as well as peer-to-peer networking that's going to be kind of locked behind that software registration. So an IPA panel can only be converted to another IPA panel, where an AFC panel can be converted to both an AFC and an IPA, as long as it has an equal or larger number of onboard circuits, a larger SLC capacity. So when we do that conversion, we're going to take all of those point descriptions, central station reporting paths, everything about that previous configuration, and we are going to write that to a new panel type. So single click panel upgrade, a very useful feature there. Below that, we have create DACR report. The DACR report is the digital alarm communication report. And I'm going to go ahead and pull up a copy of that here real quick. First of all, to create a DACR report, we have to have a central station path programmed into our configuration. If we don't have that, the software will not create this DACR report. But you're going to notice here, this is for the panel at our headquarters here in St. Louis. It has our address up top. We're reporting in contact ID, and it's got every point on the system and how it's going to report to the central station. So especially on larger systems, this can be a very easy way to get that points list to your central station. Here you can see we've got the description as it's written in the panel, how that point's going to report, the event codes for its various statuses. As we scroll down here, this is not a great example, but I'm going to go ahead and show you here. We do have subpoints also shown. So here would be an LEDK, which, like I said, that's kind of a bad example for this, but it does show how this is going to work. Here you're going to see we've got the module at address 27. I've got 27.1. and 27.2. Those are going to be the subpoints that we see in the software. Both of those inputs, now I realize in this case they're not both inputs, but both of these inputs are going to report to the central station at address number 27. So please keep in mind with those subpoints, if we're using something like a dual input module, if we have a water flow switch on input 1 and a tamper switch on input 2, that's going to be okay, because in that situation, it would show the top one, that's the module, that'd be a dual input module. 27.1 would have an event code of 113 for water flow. Input 2, or 27.2, would have an event code of 203 for tamper. So it's going to report the same address, but different event codes. So as we scroll down the list here, you can see we've got quite a few points on this DACR report. Pretty big system. This is going to save a lot of time on the phone with that central station. But when we come down here to the bottom, we even have system level event codes. 305, the system has been powered up. 601, manual test. 602, periodic test normal. 608, periodic test off normal. So it's got every code, every event code the panel can possibly send here in that report. All right. Below that, we have create point report. Now, create point report, it generates a point report, exactly what you would expect. Not nearly as powerful as that DACR report, but it does have a place in the lineup. When I was in the integration side, I really liked to give this report to my test and inspect guys, because that it has everything that's attached to the panel. Here's all of my NAC circuits on the control panel. Here you can see we've got some smoke detectors. Scroll down here, it has every single thing that's attached to the system. Here's my second SLC loop card. Come down here even further, you can see I've got a third floor power supply, second floor power supply, etc. I've got everything attached to the system right here. So it becomes a pretty handy little worksheet for those test and inspect guys. Okay, below that, we've got our recent history, the last 9 configurations that we've opened. And then, of course, exit is exiting the software. I'm going to take a quick second here and see if anybody has any questions. I will say I have all of your microphones muted, so if there are questions, please type them in the chat box, and I will happily answer them. I am going to keep my eye on that box, so if something pops up and it makes sense to talk about it right then, I will. But besides that, I will take several breaks through this presentation for questions. Okay, I'm not seeing anything there in the chat box, so we're going to go ahead and move on. But again, if you've got any questions, please do take a second and type it there in that chat box. Okay, so below the Windows ribbon, we have the transfer ribbon. That's a computer, green arrow pointing down to a circle P. That's going to be sending the configuration to the panel. Next to it, circle P, green arrow pointing up to a computer. That's going to be retrieving the configuration from the panel. Next to that is a calendar. That's uploading the history. Next to that, that's supposed to be a smoke detector. So that is uploading the detector status report. I really like our detector status report, so I'm going to take a second and talk about this. So NFPA 72, it's kind of buried in chapter 14 in the test and inspect, but it does say if your panel is situated to do live sensitivity testing, that you do not need to perform sensitivity tests as a part of your annual test and inspect. So I really like this report for that application. One of the things when I was in the integration side that we did quite a bit was I used this email reminders, and I would program that to send me an email yearly and attach both the history and the detector status report to that email, and I would use that as an annual test and inspect reminder. Get this email and it says, Smith Elementary's annual test and inspect is due, and I'd have the history and the detector status attached to it. The reason I liked both of those is they both gave me good actionable intelligence. Open up that history report. If all 4,000 history events are written in the last 3 months, I've got an incredibly active panel. What's going on? Probably going to send more than one technician. However, if I've got 10 line items written in the last year, I'm not that worried about it. Pretty healthy panel, so we're going to have a pretty easy lift. I would attach this detector status report because as we look at this report, you're going to see where this can inform my response as a part of that test and inspect. So let's go ahead and go back to the report here real quick. From left to right, first thing we have is our address column, 00:009. 00 is indicative of the built-in SLC loop, so I know that's loop 0. :009 is telling me that that is address 9 on that built-in SLC loop. Next to that, sensor type. This gives me a little snapshot of what it is I'm looking at. In this case, it's a PCD on a sounder base. I've got a photo CO detector on a sounder base. Next to that is going to be the custom description. Now, I was kind of lazy when I generated this report. I hadn't given custom names to any of these points, but it's going to say something other than 0.9, room 102, whatever the case may be. When I generated this report, how much smoke was that smoke detector seeing? That's going to be listed in the photo current column. Well, thank goodness we weren't seeing any smoke at the time. Next to that, we have our photo peak. So in this case, just under 4%. And you can see my set point is 3.5%. So at some point, that detector has gone into alarm. I want to take a quick second and talk about peak values on Potter detectors. Those peak values are held on the detector themselves, and they do not have an expiration date, with the exception of as long as that detector is powered up. So if I take the detector out of the base, I'm going to lose my peak value. If I pull my SLC off the control panel, I'm going to lose my peak values. If I send a new configuration to the control panel, the panel is going to do a full power cycle, and I'm going to lose my peak values. The reason why I'm telling you this is we can use that peak value in a very interesting way, in my opinion. So when I would send out test and inspect guys, if we had no service to do before that inspection, I would tell them, pull the SLC, count to 5, and re-land it. I wanted all of the peak values wiped off of all of those detectors. As they did their inspection, I would expect to see new peak values getting written in for smoke detectors, heat detectors, etc. The reason why I like this is this shows that I actually introduced smoke into the chamber of that smoke detector, or actually applied heat to the heat detector. When they were done with the inspection, I would have them pull a copy of this sensitivity report, and we would add that to the NFPA 72 test and inspect documentation as supplementary pages. After they'd pulled the report, I would have them pull the SLC again for about 5 seconds, because we have these emails going out once a year, and when I get this email with this detector status report on it 11 months from now, I don't want that test and inspect data in there. I only want in-service data. So I want to clear all of those peak values out. So there's the peak value, day and night sensitivity. So on Potter systems, we have the ability to change our sensitivity on a schedule, and we can do that in the software here under the sensitivity tab. And we can define when night is. So if there's a difference in sensitivity, we would see a different value between day and night. Here we don't have one, so basically day is going to be our smoke detector sensitivity. Again, kind of leaning into information from the hardware presentation, Potter smoke detectors have adjustable sensitivity of 1.1% obscuration per foot to 3.5% obscuration per foot, with 1.1% being noticeably more sensitive than 3.5. Okay, moving further to the right, we have a column labeled photo drift. So we are allowed to compensate for dirt on smoke detectors. We're allowed to compensate up to 50% of the detector set point for that drift. So the analogy I like to use is photoelectric detectors are effectively cameras looking at the world around them. When they see something they interpret as smoke, they're going to expect that to keep moving. So that little pixel that it interprets as smoke should keep moving. If that does not move over a certain number of sample cycles, the detector is going to assume that it is not smoke, that it is dirt. So that point I'm trying to make here is we can compensate for that dirt up to 50% of the set point. So the drift limit, the next column, 1.7%, is half of the set point, 3.5. If I had a detector that was currently in 1% drift, for that detector to go into alarm, it would actually need to see 4.5%, 1% being dirt, and the additional 3.5% being what it would interpret as smoke. Yes, you can take the detector apart and clean it. The information on where to do that is going to be in the 4 and the 6-inch detector base manual available on pottersignal.com. There are detailed directions on how to disassemble, clean, and reassemble that detector. So, back to this as part of an email that I'm getting in the run-up to the test and inspect. The reason I like this photo drift is I don't necessarily want to wait until that detector crosses that drift limit and I get a dirty detector trouble. So the example I was using, if the detector has a 1% drift and 1.7 is the limit, and I get this as a part of that inspection reminder, I'm going to be able to have an informed conversation with my customer about, hey, we need to clean some of these detectors before we do our inspection. At the end of that inspection, I would expect to see all of that drift back down at 0. Photo drift alert lets us know if that detector is dirty or not. Okay means it does not have a drift alert. Yes means it does. More importantly, is this smoke detector NFPA compliant? Yes or no? So we scroll across here further to the right. Now we are looking at a heat detector. When I pulled this report, what was the current temperature my heat detector was seeing? What is the peak value it is seeing? And what is its alarm set point? So in this case, 168 is the peak, 135 is the set point. So at some point in this duty cycle, this heat detector has gone into alarm. Next to that, we've got low set point and low peak. Again, please keep in mind that our heat detectors can not only track upwardly mobile temperatures for alarm and supervisory signaling, at the same time, we can track downwardly mobile temperatures for trouble or supervisory signaling. So low temperature is going to be trouble or supervisory. High temperature is going to be supervisory or alarm. So out of the box, low temp is set at 40 degrees. Now we have to enable that in the zone. It's not on automatically on every heat detector. Particular zone is doing low temperature work, but we don't need to put a separate device in for that low temperature monitoring. As we come across, there's the rate of rise peak. And then finally, we're looking at our CO detector. So the first couple of columns that we see is CO current. That is outside of a timer. When we pulled this report, how many parts per million were we seeing on our CO detector? What is the highest parts per million we have seen on our CO detector? Again, those are outside of timers. Potter CO detectors have 3 different timers. 70 parts per million sustained over 2 hours, 150 parts per million sustained over 30 minutes, 400 parts per million sustained over 10 minutes. So there you can see we've got, is it currently in a 70 parts per million timer? What is the longest it's been in a 70 parts per million timer? Same for 150, same for 400. It is worth pointing out, if your CO detector is currently in a 400 parts per million timer, I would expect to see a higher value for its current residence in 150 as well as 70. CO doesn't generally just happen. Another thing I do want to throw out there, because it seems to be a little bit of an urban legend that I still hear in dark corners of this industry, please keep in mind CO is not heavier than air. It will mix with the atmosphere. That's why we can put CO detectors at the ceiling. All right. Next to that, we've got CO life remaining. So our CO detectors do have a expiration date, and that expiration date is based on time in service. So the PAD 100 CDs have an 8-year lifespan. Any of the PAD 200 multi-sensor detectors have a 10-year lifespan. Anything in the PAD 300 series also has a 10-year lifespan on that CO detector element. But again, it has to do with duty cycle. So if I put a PAD 300 CD detector with a 10-year lifespan in service for 2 years, take it down, put it in a box, put it on the shelf for 5 years. When I take it back out of that box, it still has 8 years of life remaining because it was only in duty for 2 years. So there's life remaining, and then we've got our total runtime. I'm going to be totally honest. When I was on the integration side, I would tell our customers that these CO detectors had a 9-year lifespan. And that is simply because I was using these reports, this detector sensitivity report, detector status report, in the run-up to a test and inspect. So again, I would prefer not to wait until that detector reaches end of life. If it's got less than 1 year of life remaining, let's go ahead and replace it while we're on site. All right, to the right of that, we have what protocol is that detector talking? PAD is going to be what you're going to see almost exclusively. When Potter first started with addressable panels, we were supporting a protocol known as NOMI. NOMI has exited the life safety industry, so getting those detectors or modules is getting to be increasingly difficult. What SLC loop is this detector on? Built-in SLC, SLC 1, 2, 3, etc. Finally, the last two columns are digital device date codes. So when we were designing the PAD 300s, please keep in mind only the PAD 300s have this, we put digital device date codes on those devices. So if you pull this sensitivity report, you can see that date code. In the unlikely chance that Potter ever has a recall on detectors, we could pull this report and we could see that this detector has a 2210 date code. We could scroll over here and see that that's built-in SLC, address number 11, and now we know exactly what detector needs to be replaced. So we don't have to pull down every detector in order to check those date codes. We're able to do that digitally. The smart base date code is going to be for our sounder bases, low frequency sounder bases, and relay bases. So we have the date codes on those as well. So that's our detector status report. Big advocate for that report. I really like it. It is very, very powerful. Coming across next, we see the DCR error icon. You have to have registered software to see this. So here we have an AFC panel. If I go to general options, down here in the corner, you'll see that we don't see anything there. If I go to an IPA panel, in this case an IPA 60, you can see that we've got a checkbox for protected mode. So again, you have to have registered software for this, and we can only put IPA panels into protected mode. Now what that means is when we put the panel into protected mode, all of the detectors and modules attached to that control panel will receive a little bit of information from the control panel that says that you're protected. This is a way to protect your service account. So please keep in mind there is no difference between a smoke detector or a module for an AFC panel or an IPA. They're all going to be those PAD detectors. Anybody can go to ADI, SES, Alarm Max, etc., and purchase one of those detectors. So kind of the way I like to lean into this is, let's say you tell a customer that it's going to be $300 to replace the smoke detector, just to make up a number. It seems like a lot of customers have I've got a cousin who can do that for $75. Okay, fine. Well, they can go down to ADI and they can buy that detector. They'll take the old one down. They'll match the dip switches, put the new one up. But if your system is in protected mode, the panel's going to come up with a DCR trouble. While that detector or module is in DCR trouble, it will not activate in any way, shape, or form. You would need registered software to clear that DCR trouble off and to get that panel to go back to normal. Please keep in mind that there is nothing panel specific about that little DCR bit that gets put on that detector or module. So I used to keep an IPA 60 on my desk at the office. If we had a detector on a protected system, I could put it onto that panel. I could put that protected bit on it right there on that panel and then send a non-programming technician out and then match up the dip switches, and we would not get that DCR trouble. So there's nothing panel specific about it. Lastly, on that transfer ribbon, we have firmware. So please understand our firmware is kind of a two-step process. So up top here, you see check web for updates. When I click that box, all of these firmwares have been downloaded to my local machine. If I had an older version of firmware and I downloaded a new version, the old version would be deleted and the new version would be written in its stead. We don't need to archive those old versions of firmware. Next thing we're going to do is we're going to connect to the panel. So I'm going to recommend the IP address, and that remote access username and password is going to be what we would use to connect our PC to that control panel. We would then get the version from the panel. And it is worth pointing out that whether we're talking about firmware or a configuration, the current status of the panel is not going to stop us from sending a configuration or firmware to the panel. Panel can be in full-on alarm, and we can update the firmware without having to do a bunch of disablements. Panel can have an active supervisory on it, and we can send a new program to it. It can be an active alarm. We can send a new program to it. So then we're going to run the update. Please keep in mind it is good form to back up your panel configuration before running the update. What's going to happen then is we're going to click that run update. The panel is going to power cycle because we have to catch it at a very specific point in the boot cycle. We're going to grab it at that point. We're going to erase the old firmware, and we're going to write the new firmware in its place. So to that point, please have a good Cat5 cable. You don't want to beat up cable. You know, if we're sending a configuration to a panel and we've got kind of a ratty Cat5 cable, it's not the end of the world. We can default the panel, resend the configuration. But if we do that with firmware, we can run into some problems. So good Cat5 cable. I'm also going to recommend having your laptop plugged into the wall when we do that data transfer. It's not going to take that long. It takes about 2 minutes, but we don't want the computer to fall asleep during that transfer. We can see some issues if that occurs. So the transfer between the PC and your control panel is going to take less than 2 minutes. The panel is going to power cycle. It's going to wake back up. One thing I want to emphasize here is these firmware packages sometimes contain firmware for ancillary devices outside of the control panel. And what I mean by that is it may have a new firmware for the PSN 1000. That's probably the one that would most likely take a new firmware, but there are some other devices where we've had firmware packages written for them. So when the panel wakes up after that transfer, please check your annunciator. If it comes back up and says system normal, you know you're back in service. I'm going to highly recommend performing a test after that firmware update. However, you may see the panel come back up and say updating PSN 1000. Or if you're doing an integrated voice system, it might say updating amplifier. If that's the case, you're going to need to wait because that firmware is being transferred from the control panel to those P-Link devices over the P-Link circuit. All right, so that covers the transfer ribbon. Again, I'm not seeing any questions in the chat, so I'm going to go ahead and I'm going to keep moving here. Let me close out these couple of programs here real quick. And we are going to, the demonstration I'm going to do is going to be on the AFC 1000. We're going to go with the big control panel. First thing I want to talk about up top here, this is our navigation ribbon. Over here on the left-hand side, remote access username and password by default is capital P Potter, capital P Potter. If we change that password and we go to send this configuration down to a panel, first of all, it compels us to save that program. So please understand we're not sending the configuration from the software to the panel. We're sending the saved file to the panel. So now here we see that transfer box. And I want to talk about a couple of things in here. Most notably, the password currently shows 1234. So I would not be able to connect to that panel because that is not the password that's currently in there. Above that, you're going to see that it shows my computer's IP address. This can be very helpful for troubleshooting. So I'm going to put in a panel IP address here, and you can see that this, I get green over here on the right-hand side. Green is obviously good, where red is going to be bad. You can see here that I'm not able to connect to .27, but I am able to connect to .21. What's happening here is the software is basically pinging that panel. It's a little bit more complicated than that, but we're pinging the panel. And when we have that communication established, you can see here that it'll read me the net BIOS of the panel. So 2594 is that panel. It'll tell me what the model is, an AFC 1000. It even tells me what version of firmware this is running, 10.06. So I know that I would be able to communicate to that panel. All right, next one down, job details. If we're doing email work, especially like email reporting, status emails, alarm, trouble, supervisory, we want to have this job details filled out. AFC 1000002594. I have no frame of reference for what panel is sending me that email, whether it be alarm, trouble, or supervisory. But if I have this job details field filled out, that'll be written into the body of that email, and I know what panel I'm looking at. Even if I'm not doing email work with these panels, I'm going to highly recommend go ahead and filling this out, just as a fail-safe. What are some job site specific details about this panel? Okay, under general options, these are going to be system level decisions. One of the big things I emphasize in my software presentations is making decisions. And when I have a question, is this a system level decision? Is this a point level decision? Or is this a zone level decision? I apologize. System would be general options. Point, of course, would be in the points tab. Zones, of course, would be in the zones tab. So I want to touch on a couple of things here in the general options tab. First off, panel name. That's if we're doing software like a PotterNet or IntelliView, and it'll populate in that software. System idle message, we have to enable it, and then we get 16 characters of uppercase, lowercase, and numeric we can type in that. Now that's going to overwrite the top ribbon where normally it's going to say AFC 1000 in this case. It will auto center that message. Default outgoing email address. Within the enunciator, we have the ability to force the panel to send certain emails, and this is the email address that it's going to want to go to. I'm going to highly recommend using a non-named account here. Don't use jamesb@pottersignal.com. You probably want to use service@pottersignal.com. Below that, how do we want the events to display on the enunciator? Do we want the initial event to display on the top, or do we want the newest event to display on the top? Below that, we have SLC blank. We're probably always going to leave this normal, and we'll talk about why here in just a second, but this affects every detector and module on the system. So if we leave that SLC blank at normal, the LED is going to flash once every time the panel pulls, so about every 4 seconds. We can put it in slow, which means that LED is going to blink every other polling cycle. Or we can turn off the polling LED on every detector and module on our entire system. So this was the predecessor to us having the ability to turn the LED blink off on specific detectors and modules on our system. So now we're generally going to make that decision in the points tab. Back to general options, alarm verification. Please keep in mind that this impacts smoke detectors only. What I mean by that is a Potter addressable smoke detector element of a multi-sensor detector, or if we have an IDC6 and one of those circuits is programmed for 2-wire smoke detectors, we can put those circuits into alarm verification as well. What this means is if a smoke detector senses an alarm-causing condition, a timer will start, and if that condition persists at the expiration of that timer, then the detector will go into alarm. Below that, we have water flow delay. Please keep in mind this is not NFPA compliant. NFPA 13 is explicit in stating that the delay needs to be dictated at the input device itself. So in this case, the water flow switch. However, not all things are perfect. Sometimes water flow switches go bad, and we don't want to generate a bunch of unsilenceable nuisance alarms. So we may want to put a logical delay on. Please understand that this is a one timer for all water flows on the system. So if I have 10 risers, 10 water flow switches on my system, and I apply this 45-second delay, it's going to affect every input that is programmed as a water flow. So if I've got one switch that's bad, I would need to go and turn the other 9 down to 0, and then we would operate on just a logical delay for the time being until that water flow switch was able to be replaced. Low AC report delay. How long do we want the panel to wait before it sends a low AC report? Door holder low AC dropout. So we have the ability to program NAC and I/O circuits for door holder circuits. If we program them as door holder low AC dropout and the panel loses AC, we're only going to hold those doors open for the length of the timer shown here before we're going to just close those doors. It makes battery calculations for systems with door holder circuits on them much, much easier. Now we've got several options here. The first one being no delay, 15 seconds, 1 minute, and 5 minutes. Personally, I like 15 seconds because our panels will interpret a brownout as an AC loss. So if the panel's lost AC for 15 seconds, it's probably lost AC. And this doesn't bother me too much because if we drop those circuits, we're failing safe, we're compartmentalizing the building. Auto test time and auto test interval, fairly self-explanatory. They're here in general options. So, code does require us to send a daily auto test. This is where we would go to say what time and how often. Strobes active when silenced. Please be careful with this. This is against ADA. It is also against NFPA. But I have had fire marshals ask for this, so if they do, this is where you would go to make that change. Enable power line clock synchronization. Our panels can interpret the incoming AC, whether it be 60 hertz like we have here in North America or 50 hertz like we see in a lot of the rest of the world. We can look at that frequency and use that to synchronize our clock. Enable CO tone temporal 4 on enunciators. That's exactly what it sounds like. If a CO detector goes active, the enunciator is going to chirp out a temporal 4 as opposed to the constant tone that we would get if we're a pull station or a smoke detector. Below that, we have low temp events or supervisory. If we're doing low temperature work with a heat detector and this box is unchecked, we will have a trouble signal. If it's checked, we will get a supervisory. Below that, disable 24-hour PZT resound. Please understand this only impacts the piezos on the control panel enunciators and remote enunciators. But if this is checked, that piezo will not resound whether it's an alarm, trouble, or supervisory condition. We will not resound 24 hours later. So that's not code compliant. That's there for a very specific reason that most people are not going to use. Display time is AM, PM. If that is checked, 2 o'clock in the afternoon would show as 2 p.m. If it's unchecked, it'll show military time, so 1400. If you have internet to your PCOM port on your control panel, we don't need to set the date and the time anymore. We can synchronize to network time. Once a day, the panel is going to reach out to that time server and say, what time is it? The response will be in UTC. So we want to make sure that our time zone is set correctly so the panel can do that offset math, because UTC is going to be what time is it in London. Finally, below that, we have adjust for daylight savings time. If you live in a place where daylight savings time is not used, you would want to uncheck that box. Okay, so that's it for general options. I'm going to go ahead and wait a second here and see if we've got any questions that come in. And if we don't, then I'm going to go ahead and move on to points and then zone programming. Okay, I'm not seeing anything in the chat box, so we're going to go ahead and move on. So point programming is, again, just defining those specific points on our system. You're going to notice by default, all of those NACs and I/O circuits on a control panel are set up as general purpose. So no synchronization, just polarity correcting 24 volts. When I go to my zones, all of those circuits are in zone 1 by default. I'm going to go ahead and delete these out of zone 1. Excuse me, simply because we do have the ability to run a learn command through the enunciator on a control panel. I want to talk a little bit about this learn command here real quick. When we run a learn, if there's no configuration in the panel, it's going to find all of those detectors and modules at whatever address they're at. It's going to apply the appropriate type to those addresses, and it's going to put everything in zone 1. So me personally, I like leaving zone 1 empty, and that is because we can run a learn on a commission system and we're not going to lose any previous programming. So let's say that we've got a system that's in service and I want to add 10 smoke detectors. Okay, so I quite literally add the 10 smoke detectors to the SLC loop. I see unused device troubles come up on my enunciator. I run the learn SLC command. It's going to grab those 10 detectors and it's going to dump them in zone 1. So not having anything in zone 1 kind of gives those detectors a soft place to land. So the software says you have to have a zone 1. It doesn't say that there needs to be anything in zone 1. A little bit more about that learn command. So let's say we've got a fully commissioned system and I want to remove those 10 smoke detectors. So again, I quite literally just remove the detectors. I show missing devices on my enunciator. I run the learn command, and it simply strikes those devices from the program. Last, certainly not least, is if I've got a smoke detector and I want to change it to a heat detector, I would pull down the smoke, put up the heat, and of course I'm going to have a device mismatch. Software is expecting to see a smoke. Now there's a heat. I run the learn command, and let's say that smoke detector was in 5 zones. I now have a heat detector in those same 5 zones. So please be aware of that. And we're not losing any other programming when we do those things. So me personally, I like to leave zone 1 empty. I'm going to start programming on zone 2. So now when we go back to our points, you're going to see I've got all of these highlighted in red. That is an audit error. One of the basic rules of our software is if I have a point with an assigned function, it has to be in a zone. Now, there's a couple of exceptions to that. We'll talk more about that in a minute, but it has to be in a zone if it's been given a function. So I'm going to come here. I'm going to select function on the top one. I'm going to press and hold shift, select function on the bottom. And I know you can't really see, the contrast is pretty light, but all of those are highlighted. I can now right click, select unused, and change all of those circuits to unused. Now, those circuits are quite literally turned off. If I were to meter those circuits on the control panel, I would see no voltage. They don't require an end-of-line resistor. They've just simply been turned off. So when they're unused, of course, I don't have an audit error. As a matter of fact, if I were to go and put one of those in a zone, it's going to give me an audit error, and it's going to say you can't put an unused point into a zone. It's just not going to allow that. All right, so back to points. The first scenario that I want to program is going to be a basic sprinkler monitoring scenario. So of course, for that module, I'm going to go ahead and use a dual input module. Now, I highly recommend naming the module. If this module were to go into trouble, point 1 doesn't mean a whole lot to me. Riser 1 gives me some sort of frame of context. Now, I'm going to name both of these subpoints riser 1 as well. And that is because when I give it a function, in this case, water flow and tamper, anything past contact input will also display on the enunciator. So I don't need to call it riser 1 water flow for that custom description, because on the enunciator, it would say riser 1 water flow, water flow. So I can just name the point riser 1. It'll show as riser 1 water flow, riser 1 tamper. You're going to see tamper comes in as a supervisory automatically. All right, code also says we need to have a smoke detector above the panel, so I'm going to select the pad PD. Notice it's not a pad 100, 200, or 300 PD. As far as the software is concerned, a smoke detector is a smoke detector, doesn't particularly care, so that's going to be a Potter addressable smoke detector. Now, I'm going to go ahead and call this FACP smoke. I'm putting smoke at the end of that because if I don't, it would show as FACP PD. So that can be a little confusing. So I'm going to go ahead and add smoke to the end of that description. Code also says we need to have a pull station, and you'll notice in the list here, pull station is not an option. And that's because all that it is a pull station with a miniature input module on the back. So I'm going to select that pad SIM or MIM. We're going to call it FACP. It'll display as FACP pull station. So I'm going to go ahead and do a water flow bell here. So I'm going to select NAC general purpose. I'm going to title this water flow bell. I'm going to do a couple of other points because I think it's exemplary for probably 80% of the systems we do. So I'm going to do another smoke detector here. This will be lobby smoke. This one, we're going to make it a front door pull station. So we'll title it front door. Simmer MIM, there we go. Now because of that, we need additional evacuation. So I'm going to come up here, I'm going to make this circuit a Gentex synchronization. So we'll say that's first floor NACS. Now, I named this circuit first floor NACS EOL room 116. The only time that's going to show on the annunciator is if that circuit's in trouble, and if that circuit's in trouble, one thing our service tech needs to know is where is that end-of-line resistor? So this is an easy way to give them that information. I'm a big advocate for take a couple of seconds and think about the guy that comes behind you. This isn't necessarily a Potter thing, but it is something I kind of like to highlight. So I'm going to do another NAC circuit, but this one we're going to do system sensor. And we'll say this is up on the second floor. And again, I'll name it that EOL. Now, please keep in mind that these two circuits, even though they have different synchronization protocols, because of our QuadraSync, these two circuits will synchronize together. As long as I have Gentex appliances on circuit number 2, where I have that Gentex synchronization applied, and system sensor on circuit number 3, where I've given it the system sensor sync, circuits 2 and 3 will synchronize visibly together. As a matter of fact, they're going to sync audibly together as well. The only one that's not going to synchronize audibly will be wheel lock. For one reason, or for some reason, I apologize. Wheel lock is 180 degrees out of phase audibly, but they will visibly synchronize. Okay, so the functions of the I/O circuits, that's very good. The functions of the I/O, it's a longer list. It's got all of the possible inputs. So that's going to be contact input is the prefix. And when I come down here to the bottom, it's got all of the available outputs as well. Conventional NAC would be indicative of an output. So contact input will be our input types. Conventional NAC will be our output types. And we can have those be any of the things on the list, and they're all independently programmable. So, to that point, just for fun, let's go ahead and make this one a pull station. We can make this one a NAC. We can make it an aux constant circuit, any of those output types that we want. Well, that was a NAC circuit, but I think you understand the point. So I'm going to go ahead and change both of these to unused for the time being. But yes, on those I/O circuits, which are going to show 7, 8, 9, and 10, because this is a large format panel, so I've got 6 NACs, and then built-in power supplies indicative of circuits that reside on the control panel. 7 would be I/O circuit 1, 8 would be 2, etc. Any of the input or output options we have available for those I/Os. Okay, so let's go ahead and go to zones. First thing I'm going to do is I'm going to click Add Zone. We're just going to add one zone. Now, normally, people have a tendency to think input to output when programming fire alarms. I pull the pull station and the horn strobe goes off. And that's all well and good, but on a Potter system, I like to think of it from output to input. So my thought process is going to be the horn strobe goes off with these set of rules because I've pulled the pull station. I'm going to kind of recommend backing into the zone. So the first zone I want to do is going to be the water flow bell. So here I'm going to come to my points list, and if I'm going output to input, I'm going to grab the water flow bell, drag and drop it down here into this window, this bucket as I like to call it. And then I'm going to come over here and I'm going to grab my water flow switch, drag and drop it into that zone. Now when the water flow goes active, circuit number 1 is going to fire. One of the most important things to keep in mind when programming a Potter fire alarm panel is zone rules, especially silenceable and latching. Every single zone you program on a Potter fire alarm panel, you need to ask yourself, should this zone be silenceable? Should this zone be latching? So in the case of this water flow bell, obviously we do not want it to be silenceable, so I'm going to uncheck that. I'm going to make the argument for it to be non-latching as well. And here's why. Now, I realize that code differs, so there are places where you are not going to do this, but this offers me the opportunity to talk about behaviors here. So, originally, that water flow appliance most likely was a water gong. So if water was flowing, it caused the cups in the pipe to spin, which would cause the gong to sound. Now, we've generally moved away from water gongs, so they do still exist in some places. And now code says that we could run, say, a 120 circuit through one side of that water flow switch and have the water flow switch itself actually control that appliance on the exterior of the building. So if that were the case, if the water flow switch is active, that bell would be sounding. And if the water flow switch, for whatever reason, returns to normal, the bell would silence automatically. So if somebody were to come and close that tamper valve, the bell would silence. We can achieve that same behavior, in this case, by not latching that zone. Water flow is active, the bell is sounding. The water flow is not active, the bell silences automatically. So if that bell is sounding and we press the silence button, it's not going to turn off that output. But if that water flow switch returns to normal, then it will silence automatically. The reason why NFPA wants this behavior on those appliances is we can offer the fire department several pieces of actionable intelligence by simply having this appliance behave in this manner. First and foremost is water flowing? Is water currently flowing? If that bell is sounding, we know that water is flowing. Number 2, most often, we try and put that appliance right behind that riser on the exterior of the building. So, this offers the fire department another piece of actionable intelligence. More often than not, the fire department is going to turn the sprinkler system off when they arrive on the scene. That protection process has already started, and they're generally going to turn it off. I'm going to tell you why they're generally going to turn it off. Firefighters have a hard enough time decontaminating their turnout gear after a fire response. If you've ever seen a sprinkler system dump, it is most likely very dirty and smelly water. They don't want that dumping on all their turnout gear. So, if they're going to turn it off, this also tells us, geographically speaking, where do I need to go to turn the sprinkler system off? Number 3, quite often in line with that riser, we have an FDC. And if they're going to leave the sprinkler system running, there's a very good chance that there's not going to be enough pressure to charge hoses off of that FDC. So if that bell is sounding, they probably want to put a variable pressure pump in line with that FDC in their hoses. So I'm going to say, for this example, non-silenceable and non-latching. I do want to go ahead and give this zone a name, and I'm going to make that name a reflection of the control process that we're doing. As we build out this program, I think you will see the benefit of naming your zones a reflection of that control process. And again, it has to do with thinking about the guy that comes behind you. So that's our first zone. Next zone, add another zone here, And this, of course, is also going to be a water flow zone, but it's going to be my building notification. So I'm going to bring in that first and second floor NAC as well as the water flow. And we're going to go ahead and call this water flow building. Non-silenceable, but I'm going to leave this latching as opposed to unlatching. So, here's the scenario. Sprinkler head pops, water's flowing. I've got my water flow bell on the outside of the building that's sounding, my first and second floor NACs on the inside of the building that are sounding. I hit the silence button, nothing silences, everything keeps sounding. Fire department arrives, they close that valve, the bell on the exterior of the building stops sounding, but my notification on the inside of the building is continuing to sound. Just because somebody turned off the sprinkler system does not mean that we want to stop our evacuation process. So I've got non-silenceable and latching. So that's why we have two separate zones there, because there's a difference in my rules. Those difference in rules, most of the time being silenceable and latching, is what's going to cause us to make another zone. So now we've got two zones. I'm going to go ahead and do a third zone. And this third zone is going to be my general alarm zone. It is worth pointing out at this point that the small format panels have 99 software zones. The large format panels have 1,500 software zones. We are not limited to the number of zones any specific point can be in. So I can have a large format panel with 1,500 zones, and I can put a single water flow switch in all 1,500 zones. We're not going to be limited to the number of zones a point can be in. So here in the general alarm, I'm going to drag my first and second floor NACs in there, and now I'm going to grab those other devices, my smoke detector, my pull stations, etc., all of those general alarm things. Now, I'm going to leave this zone silenceable, but I am also going to leave it latching. So if a smoke detector goes off, we can hit the silence button and silence that notification. But just because smoke clears out of the chamber of one of those smoke detectors does not mean that we want to automatically silence that evacuation. So I'm going to go ahead and leave that latching. Last zone I'm going to do in this example here is going to be for my tamper switch. Now here I'm just going to drag in the tamper because it allows me to show you one of those audit errors. So when I mouse over this highlighted section, it tells me exactly what it doesn't like. And I realize it might be a little hard to read it on the screen, so I'll read this out. When I mouse over it, it says built-in SLC riser 1.2 cannot be assigned to zone 5, because a point with the function contact input tamper cannot be assigned to a zone with the style alarm. Long story short, supervisory point cannot go into an alarm style zone. So I'm going to change this to a supervisory style zone. So to that point, notice we didn't have an issue with our water flow here in the alarm style zone. And that's because an alarm is an alarm. If we're reporting by point, this will not be an issue. If we're reporting by zone, we would want to change this zone style to water flow, because that's what this zone is doing. So we want to send the correct event code. Most of the time, we're going to be reporting by point. So back to our tamper zone here. Please keep in mind that we can do silly stuff here. I can put a NAC circuit in that zone, and if somebody closes that control valve, now those horn strobes are going to sound. We're not going to throw an audit error for that. So I'm going to go ahead and get rid of that, but please keep that in mind. Now, this being a tamper zone, I am going to say that this should be silenceable. I'm also going to make it non-latching. And the reason why is if that control valve is returned to normal, I want to go ahead and put that panel back to system normal automatically. Now, I want to talk about the difference between supervisory and water flow or an alarm style zone here when it comes to latching. If it's an alarm style zone, like that water flow bell, it's basically input to output tracking. If the switch is currently active, the output is currently sounding. If the input is currently normal, then the output is turned off. However, that alarm is going to latch in on the annunciator, and to clear it off of the annunciator, we have to reset the panel. Supervisory style zone, we have the same thing, input to output, if there was an output in that zone, but that annunciator is going to return to normal when the condition returns to normal. Right now, in this scenario, that's not terribly important. It will become important in a conversation that we're going to have in a couple of minutes here, so please keep that in mind. So this scenario is probably 80% of the fire alarm panels we do. Little 4-zone panels, we do some sprinkler monitoring, we've got general alarm, supervisory, down and dirty. I do want to do a couple more scenarios for you though, because it offers the opportunity to talk about a couple of more things. So we're going to head back to our points. I'm going to scroll down a little bit here, and the next scenario I'm going to do is elevator recall. Now, in my experience, most people program elevator recall correctly, but this offers me the opportunity to talk a little bit about how the fire department responds and why we do the things that we do. So first things I'm going to add are going to be a couple of smoke detectors. Now, I realize we're building out a 2-story building, so elevator recall is a little ridiculous here, but let's go ahead and make believe that the building's larger. So there's my first and second floor elevator lobby smokes. I'm going to go ahead and say that the elevator, shaft, and mechanical room are sprinkled as well. So because of that, there's this allows me to talk a little bit about a new code thing. Recently, ASME, or the American Society of Mechanical Engineers, said that they no longer want serviceable fire alarm devices in elevator shafts. The service response becomes much more complicated. You have to have an elevator technician out as well as your fire alarm technician. You have people riding on the top of cars. It can be pretty dangerous. So ASME said we don't want fire alarm devices that require direct service in the top of elevator shafts anymore. They did put a couple of caveats in there, one of which says that you can cut in an access panel. Let's be honest, that's kind of ridiculous. If you know anything about how elevator shafts are built and the fire rating that they have, cutting in an access panel is a very expensive conversation. So what we can do is we can put in non-serviceable elements into the shaft, and then the serviceable elements would be in that easily accessible space. So to that point, what we're going to do here, I'm just going to go ahead and call this top of shaft. And this is going to be my top of shaft ASD smoke. So I'm going to use an aspirating smoke detector here. On my functions, when I look at this, I'm going to just go with fire alarm. I don't have a smoke detector in there. It's just going to be a blanket fire alarm. And this here is going to be my top of shaft linear heat detection. So again, I'm going to make that fire alarm. So now I can put that control unit for that aspirating smoke detector in an easily accessible space, and then I've only got my tubing in the shaft. Linear heat detection, I can put that module and run that wire out through the top of the shaft, bring it back into that box, put my end-of-line resistor, and then all of that service and inspection, testing work, etc., takes place in that easily accessible space. So that'll take care of the top of shaft. I'm going to go ahead and put a PhD in the mechanical room. Now, it is worth pointing out here that if I have a multi-sensor detector with a heat detector element on it, that heat detector is going to be locked at 135 degrees for its set point. I no longer have the ability to adjust the heat detector set point. And that has to do with the installation temperature of the smoke detector being 115 degrees Fahrenheit. So mechanical room, we're generally not going to have those sort of environmental concerns. So we'll go ahead and use that there. And we'll say that 135-degree heat is acceptable for that application. If we need a higher level of heat detector for that mechanical room because of the sprinkler heads that are going to be getting put in, then we would want to go with just a pad HD. All right, so that takes care of the initiation side of elevator recall. Now, I'm going to need to do control relays. I'm going to start off with just 3 relays, and that'll be my primary recall, my alternate recall, and my fire hat. The reason I didn't use an RM for my shunt trip is hand in glove with the shunt trip is monitoring of that shunt trip. So I'm going to go ahead and use an OROI because I can be more efficient with my addresses and my physical modules that are put in. So you'll notice there that the relay is first, so that'll be my shunt trip, and then below that is going to be my shunt monitor. Now generally on that monitor we're going to have that signal as supervisory, so I'm going to make it contact input supervisory. The rest of my relays I'm going to leave as general purpose. Before we head to zones, I really want to emphasize, please keep in mind that relays that are programmed as general purpose are silenceable relays. So this is going to impact our zones. So now when I come back to zones, I'm going to click add zone, and instead of doing just one zone, I'm going to go ahead and add a total of 4 zones. So now we've got the 4 zones. If I come here and select zone 6, press and hold shift and select that, now all of those zones are available up top. I can come here and name my zones, primary recall, just hit enter, and it will drop me down to the next one. So that'll be my alternate, that'll be my fire hat, this will be my shunt trip. Of course, we want all of these zones to be non-silenceable, so here's another little trick. We can change a bunch of zone rules at the same time. Select the top, press and hold shift, select the bottom, right click. I can uncheck all of those at the same time. And then you'll notice latching, of course, we want to go ahead and leave that latched in. So now I'm going to select just my primary recall. We're going to come down here. We're going to grab that primary recall relay. And of course, that would be the 2nd floor smoke detector, 3rd floor, 4th floor, etc. Alternate recall, of course, is going to be the alternate recall relay, and in this case, 1st floor smoke detector. Now, one thing I want to emphasize here is when I'm teaching this live class, I do like to ask people in the class, are we motivated to keep elevators in service for as long as possible in a fire event? And invariably, there are people who say no. And the answer is yes, we are motivated. We do want to keep those elevators in service for as long as possible. And the reason why is if we've got a 10-story building and somebody in a wheelchair on the 10th floor, taking the elevator out of service because somebody pulled a pull station, well, that's not giving them a very effective evacuation route. They're going to have a very difficult time getting out of the building. So, to that point, when do we take elevators out of service? Well, we take elevators out of service because smoke has been indicated in the elevator lobby of one of the floors. So the point there being is we no longer have a tenable evacuation route in that elevator. So we want to go ahead and take it out of service at that point. So now stepping forward to the fire hat, please keep in mind not all elevators are the same, but in my experience, if the fire department arrives, they're going to put that elevator back in service. And that is because fire hose is not light, so they're going to take that key and they're going to put that elevator into firefighter operation mode. When they do that, that fire hat light is going to come on solid, indicating that the elevator is in firefighter operation mode. So now let's talk about the fire hat. So here we're going to drag the relay in, and what makes the fire hat activate, of course, is going to be our smoke detectors in the top of shaft or in the mechanical room. When those smoke detectors activate and that relay changes state, the only thing that happens is that fire hat light goes from solid to flashing. So it's strictly informative. It's telling the firefighter or firefighters in that elevator that it's time to seriously consider getting out of that car. So to that next point, what is shunt trip? Well, shunt trip is we are turning off power to the car. We're turning off the elevator power entirely. We're not just taking it out of service, we're turning it off. And the reason why we're doing that is because it's getting too hot. Our heat detector has tripped. And we want to make sure that our heat detector trips at a temperature before the sprinkler head activates. So again, I'm going to put a big asterisk behind this statement. I have seen spreads of approximately 20 degrees between the heat detector and the sprinkler head. So if I've got a 135 degree head and there's a 165 sprinkler head in there, I've got 30 degrees. I think that that's appropriate. That's okay. But we want to make sure that our heat detector is at a lower temperature than that sprinkler head. Now, when we scroll over in our zone rules, you're going to notice that there's a rule that says output activation delay. Why would we ever delay the activation of an output on a fire alarm? Shunt trip is pretty much it. I did a 25-story building where the fire marshal asked if we could delay the shunt trip. And I said, yeah, we can delay the activation of the shunt trip. And he asked me to time the following process. In the elevator, I recognize that the fire hat has gone from solid to flashing. Where am I in the hoistway? What direction am I traveling? Make an appropriate decision about where I'm going to go, get there, have the doors open fully, and step off of the car. He wanted all of this to happen before the shunt trip. And the reason why is this. Building code says at no point in the hoistway can the elevator door be impeded by building structure by more than 30%. In other words, the floor of the building. There are people that think if you get into a tall elevator that you're in a fancy building. No, you're in a building with thick floors is what it comes down to. So here's the deal. If we hit that shunt trip immediately, we pry open the doors, we may have an opening up top that's less than 24 inches. I can tell you that most firefighters who have been trained in firefighter elevator operation have been told if they see that fire hat go from solid to flashing, they need to take the next 3 minutes of their life into very serious consideration. And the first thing they're going to do is they're going to pull down that SCBA. They're going to put on that breathing apparatus. So now back to we've pried open the doors. I've only got a 24-inch opening up top. I'm going to have a very difficult time if I'm wearing turnout gear. I've got an oxygen tank on my back. I'm going to have a difficult time getting out of that elevator to the upper opening. If I go out to the bottom opening, I stand a chance of maybe sliding under that elevator and falling 22 floors to my death. Not a very good look there. So maybe we want to delay the activation of that output. So when I timed that process, I kept coming up with 12 seconds. Fire marshal said, that's all well and good. However, you don't have a radio blaring in your ear. You're not pumping full of adrenaline, etc. I want an additional 5 seconds. So 17 seconds is what we delayed that shunt trip. Now, I was a little concerned here because I had in that situation, I had a 145 degree heat detector, 165 degree head in the top of shaft. And I was a little concerned with that 17-second delay. If we didn't cross that event horizon, we were getting very close. Reached out to the fire engineer, FPE, and said, hey, here's our situation. What should we do? He said, how low can I take the heat detector? And I said 135. And he said that he wanted an additional 2 degrees of separation per second that we had applied to that delay. So he wanted an additional 35 degrees. I had 20 degrees to start. Now I've added 35 more. So I've got 55 degrees of separation. So I can only go as low as 135. That means my sprinkler head needs to be 190. And he reached out to the sprinkler fitter and said, hey, we need to put a higher value head there. His point was we were going to dump water. If we get to 165, we're going to get to 190. We're going to dump water. But he wanted to give that firefighter a chance. Now, keep in mind, That whole conversation is kind of antiquated today because most new elevators come with a battery backup built on the roof of the car. So with that battery backup on the nose, the purpose of it is if the building loses AC mains, that we're going to return the car to the first floor and open the door. So we're not trapping people in the elevator. But in the case of shunt trip, that same thing's going to happen. So more likely than not, we're going to go ahead and hit that shunt trip automatically and allow that battery backup to take control. Do want to put an asterisk behind that statement because there are places where they want you to shunt trip that battery backup as well. So just be prepared to have those conversations. So I'm going to do one more zone here, and I'm going to do that zone for my shunt monitor. I'm going to add another zone here. Of course, that's going to be shunt monitor. I'm going to make it a supervisory style zone because I know it's a supervisory style signal. So we'll bring that monitor in. I'm going to leave it silenceable and non-latching. Now, that could have gone in the same zone as that tamper. You're going to notice they're both supervisory, both silenceable, both non-latching. Absolutely could have done that. The panel's going to behave the same. I could have just made a blanket supervisory zone. I'm a big advocate for doing additional zones because, as you see here, as we build this out, we quite literally have spelled out all of the control functions we're doing on this panel here on the zone list. So when that next service tech or inspector comes and pulls a copy of this program, they don't have to sort through a bunch of stuff to figure out what it is we're doing. It's quite literally spelled out here in the zone list. Now, I'm going to tell a little story on myself here. I can tell you the number of times that I have programmed elevator recall correctly the first time out. I'll program it just like you've seen here, and I will leave my helper at the annunciator. I'll go to one of the elevator smokes, I'll smoke it, and the elevator will recall, and I'll recognize pretty quickly that it's quiet in the building. My horn strobes haven't gone off. We're going to come back to that in a second. I want you to understand a very important concept here. If I have a pull station and a horn strobe in one zone that is silenceable and latching, same pull station, same horn strobe, and another zone that is non-silenceable and non-latching, the software is not going to throw you an audit error. What's going to happen is this. When that pull station goes into alarm, the panel is going to start at zone 1 and run through all of the zones. And when it sees a conflict in those rules, it's going to say, I don't know what to do. So the panel is going to do what it interprets as the safest behavior. So silenceable versus non-silenceable, obviously non-silenceable is the safer behavior. Latching versus non-latching is going to be the safest behavior. So now the panel is going to cherry pick the rules. So if you have a situation where your panel is not behaving the way that you think that it should, please take a breath and ask yourself, is the panel doing what it interprets is the safest behavior? I'm going to show you a trick for how to troubleshoot that. So back to my situation where the horn strobes aren't going off. So if I look at this first floor elevator smoke, you're going to notice I get these little triangles when I add them in these points into zones. When I click that triangle, it shows me all of the zones that point is in. So back to the pull station horn strobe situation, if that were the case, I could come to that pull station and say, it's in general alarm and some other zone. Now I don't have to scrape through 10 zones to find where the issue is. I'm only going to go through the zones that input or output point is in. So back to my situation, of course my horn strobes aren't firing because it's only an alternate recall. I look at alternate recall, there's no horn strobes in there. So now if I go to my general alarm zone and I drag that smoke detector in, you'll see that it automatically populates in that list. Of course, I want to drag in my second floor elevator. I want to drag in my top of shaft as well as the mechanical room. I want to even show you one more trick here. That mechanical room, multi-element, it's got the subpoints. If I grab the detector up here, so that whole number, you drag it in, you can kind of see there, it looks like it's got 3 lines. Well, when we scroll down, you can see it's drug in both the smoke and the heat at the same time. So I didn't need to drag those in independently. So now my horn strobes are going to sound when those detectors go off, as well as activate those relays. I'm going to take a quick second here. If anybody has any questions, go ahead and type them in. The next scenario I'm going to do is we're going to do some sounder bases. So I'm going to program a couple of sounder base scenarios, and then we'll wrap this up. So any questions, please type them in the chat box. Okay, I'm not seeing any questions, so we're going to go ahead and move on. Next scenario we're going to do here is going to be sounder bases. So I'm going to go back to my points, and again, I want to show you guys a couple of tricks here. So if I name my point before I assign it a function, so in this case we'll call it room 119, and then I come here and I select the PCD in split mode, it names those subpoints automatically. Now, if I want to put that PCD detector, photo CO detector, on a sounder base, now I'm going to go to function, and instead of sensor only, I'm going to park it on a sounder base or low frequency sounder base. So now I get that third subpoint. I get that subpoint for the sounder base as well. Please keep in mind sounder bases are part of a two-part output. Sounder bases require a NAC or an I/O circuit that is designated is sounder base power. So I'm going to come back up top here. We're going to grab NAC 4, and we're going to make that sounder base power. Please keep in mind that sounder base power circuit is what is going to pulse the temporal 3 or temporal 4 pattern. This circuit is what's going to dictate the pattern, not the sounder base down here. All right, so now that we've got our sounder base and our sounder base power, as well as our detectors, we're going to go ahead and do another one. This one, let's make it room 226, and we're going to do a suite. So I'm going to make it 226A. I highlight the whole thing, Control C, that copies it, PCD split, put it on a sounder base, we're good to go. Come down here, V, we'll paste it, so we'll make that B, and I want a PCD in split mode, and we'll put it on a sounder base. So now we're going to do a couple of different scenarios here. I've got 3 detectors, all on sounder bases, all in split mode. So we're going to come here to our zones, and because I've got 3 detectors, well, I've got 2 rooms. I think that's the more important part, but I've got 2 different detection technologies. I'm actually going to do a total of 4 zones. So we'll add our 4 zones here. We'll come down here. We're going to select all 4 of the zones. And now we're going to do room 119 smoke, room 119 CO, room 226 smoke, not A or B. We're going to do kind of a multi-station there. And then this will be room 226 CO. So now, on my smoke detectors, I'm going to make my smoke detectors silenceable and non-latching. I want them to behave like a single station smoke alarm I might have in the house. If it goes active, I want to be able to wave some paper or something in front of it, clear the chamber, and have it silence automatically. So we're going to go with silenceable and non-latching. My CO detectors, I'm going to do exactly the opposite. We're going to go non-silenceable and latching. If I'm trying to wave paper in front of a CO detector to get to silence, all I'm going to do is lower my blood oxygen level, which means I'm going to pass out from that CO faster. So we want to keep that is sounding for as long as possible. The output pattern here is the pattern that the sounder base power circuit is going to pulse when that zone goes active. So my smoke detectors, I want them to be a temporal 3. My CO detectors, I want them to pulse a temporal 4. All right, so those are my zone rules. If I have multiple zones selected in my zone rules up top and I grab a point and drop it, I have added that point to every zone I had selected up top. So I don't need to add sounder base power to all 4 of those zones independently. I can do it all at one time. So I just drop that circuit into all of those. Now here, I'm just going to go to 119, and I'm going to select both the smoke and the CO, and I'm going to drag the sounder base in. Now I dropped it into both of those zones. 226, I'm going to do the same thing. Grab that sounder base, but I'm going to press and hold Control, select the second one. Now I can drag and drop both of the sounder bases into both of those zones. So now all I've got to do is just a little bit of housekeeping here. On the smoke detector, 119, grab 119 smoke, drop it in. That smoke detector goes active. Sounder base power circuit's going to sound a temporal 3. Sounder base is going to pass that pattern along. Go to the CO detector, drag the CO in the zone. CO goes active. Sounder base power circuit's going to pulse a temporal 4. And that sounder base is going to pass it along. Please please understand there is signaling priority on that sounder base power circuit. We will go from temporal 4 to temporal 3. We will not go from 3 to 4. So if a CO detector activates this sounder base power circuit, that circuit's going to pulse a temporal 4. If a smoke detector further down the line goes active, now that circuit's going to pulse a temporal 3, and both sounder bases are going to sound a temporal 3. Go to 226, same thing. I'm going to grab the first smoke detector, hold Control, grab the second, drag both of the smoke detectors into that zone. Either one goes active. Sounder base power circuit pulses a temporal 3, and both sounder bases are going to sound. Same with the CO. Grab one CO, grab the other, same concept. So that's it for the basic zone programming on our software. We do have a little bit of time, so there are some other things that I would like to show you. Give me just a second here. I've got a program that I want to open real quick. I apologize, I should have already had this open, but we are running a little bit early. Okay, so this program has got a whole lot of points in it, okay? There's a whole lot of points here. And we've got all sorts of rooms in here. They're all supervisory. We've got all sorts of stuff. When we go to our zones, we've got no zones. So I want to show you a little trick for doing a whole lot of zones at once. Now, I know for a fact that we have a total of 35 rooms. I'm going to go ahead and program all 35 of these rooms here. But I'm going to do a trick here. I'm going to look at this description. I'm going to press that one, and now I'm going to hold Control. 102, 103, 104, 105 ADA. I'm going to scroll down here. We're going to get 201, 202, 203, 204, 5, 6, 7, 8, 9, 10 ADA. Going to do the same on the third floor. 301, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same on the fourth floor. 401, 402, 3, 4, 5, 6, 7, 8, 9. Oh, didn't want that one. Do want 1088. Now I've been holding Control the entire time. Okay? Going to release Control. Control C. I've copied all of that to the clipboard. I'm going to go to Zones, Add Zone. I'm going to do a total of 35 zones. Select the top one. Select the bottom one. Come here. Just tap into where that says Zone 1. Control V. Just named all of those zones. All of those zones are all named. Now, these are all smoke detectors, and they're all supervisory. So I'm going to come here, select Alarm up top, Alarm on the bottom, right-click, make them all supervisory. I want them all to be silenceable, so we'll leave that. I want them all to be non-latching. Use that Shift key, select them all, uncheck them all. They're all going to have sounder-based power. I want them all to be TEM3, so same thing. Press and hold Shift. Apply temporal 3 to all of them. So now we're going to do some bulk loading. So there's my first floor. First floor sounder base power. You're going to notice I've got all of those first floor rooms selected there. Drop the sounder base power in. Only had to do it once. Do the same with the second floor. Select all of the second floor rooms. Drag the sounder base power in. Come down here. We're going to do the same for the third floor. I know these are down here at the bottom. Third floor sounder base power. Not least, fourth floor, drag it in. So now I've basically built the very, very simple part of all of these rooms. I'm going to show you another trick though. Over here in the points, if I grab any of these column headers and I come up here and run that up a little bit. So I click it and run it up here now where it says group by area, and I can do that with any of the headers. Now we've got everything sorted by name. So now we're looking for first floor room 101. You're going to see here it says 2 items. When I drag and drop that in, there's the smoke and the sounder base. I just drug both of those in. Can do the same with 102, 103, 104, 105. Scroll down there, we'll get to the 200s. 201, 202, 3, 4. The point I'm trying to make here is that I can program all 35 of these zones in less than 5 minutes. No, Christopher, unfortunately, we cannot do it from a spreadsheet. That's where I figured this trick out, though. A lot of time spent in Excel. So it's the same kind of concept. But no, unfortunately, we cannot just do it from a spreadsheet. But I can go through and I can do all of these rooms super, super fast. 208, 209. Oh, wait, looks like 209 has a bunch of stuff in there. No, don't worry, Chris, your secret's safe with me. Here's my point. I spent the first part of this presentation showing you guys the basic ins and outs. I'm a big advocate for I want everybody to leave these trainings with something. Obviously, you've picked up a pretty nice trick here where you can go through and you can just quite literally grip it and rip it. You're off to the races. This one even had a knack module in it. Go ahead and throw it in the zone because I'm doing it all based on that point name. So as long as all of my points have got the same name, third, room 301, etc., as long as all of those points have got that exact same name, this makes life so much easier. But going through and doing all of that bulk naming, that bulk rule changing, whole thing, very, very easy. So, I mean, I'm just kind of conversationally talking as I'm building out all of these rooms. I don't even really need to be paying that much attention. I need to make sure I'm grabbing the right thing. But I had 35 zones that could have taken me, if I would have been dragging stuff independently, that could have taken me quite a bit of time to do. In this case, it's not taking me all that long at all, other than I can't find the last couple of points here. 402, 403, 4, 5, 6, 7, 8, 9. Oh, just went to 1. And 10. Easy peasy. Easy peasy. So to undo this view, we're going to grab where it says name, going to run it back down there. Go back to that standard view. We can use that for any of these header types. I want to find all of my smoke detectors. Drag type up there. Now when we look in the list, I've got 63 smoke detectors in here. Now I can click that triangle and I can see all of just the smoke detectors. If I wanted to see all of my circuit functions, I could come up here. We can scroll down here. Oh, I've got 4 circuits that are running Gentex Sync. Very, very useful way of sorting out here. Other Excel kind of things work. We can sort by device. We can go by address. That doesn't really make a whole lot of sense. We can sort by name, A to Z, Z to A. We can go by type like that. But if we're going to do type, I like just bringing it up top there. And now I can see all of just those smoke detectors. So, just did those 35 zones in a couple of minutes. Less than 6 minutes, and I've been kind of chatting the whole time. I do appreciate everybody coming today. That's a very big commitment on your part to come and join me, so I really do appreciate it.
For more information about Potter products, please visit our website at pottersignal.com. To access additional training resources, check out our online training portal at academy.pottersignal.com. Stay connected with us on social media for the latest updates and news.